All right. So fourth breakpoint, yeah? 6,000 people, so exciting. Who here has medlads? Yeah. All right. That's not the purpose of my talk, though. I am part of Solana ecosystem since 2018, and I founded and I run Rockaway X. We are basically infrastructure engineering firm, so we run validators. Tomáš here is the god himself. We run validators. We also provide liquidity to DeFi protocols, like, for example, Camino. We run solvers for Wormhole, Mayan, dBridge. So think about us a bit like Citadel, running infra, providing liquidity, running the transactions. On top of it, in 2021, with Dusan, my business partner back then, we realized that actually Solana will also be having hacking risks, just like Ethereum. And we were based back then in Prague. Our office was just in front of Czech Technical University, and we noticed there were a group of very smart professors at the Czech Technical University, because actually not many people know, but 30 years ago, all the antivirus software, Avast, AVG, Asset, they were actually created in the Czech Republic. So there is a massive, machine learning / AI know-how within every university, because then these antivirus companies are actually sponsoring and giving grants to those universities. And so with Dusan, we noticed those professors, and we told them, hey, let's create a smart contract auditing firm. So Aki was born in 2021. Aki has a team of 20 people. We actually also invested into Aki, $500,000. They never used it. They were profitable from day one. And they are now doing three things. The first one is smart contract audits, typical smart contract audits, a 3-month project. Second thing is they are running schools of programming for Solana, and also now an auditing school. And the third thing they are doing is publishing open source auditing tools. So we'll talk about this today. In terms of their audits, they have 134 audits that they run so far for around 40 clients. So on average, it's 3 audits per client. Their Solana clients are Marinade, Neon, Helio, and their EVM clients are Lido or Safe, for example, and they're continuously doing audits of those companies, including the fastest. In terms of their schools, they had so far around 3,400 applicants. The 5th school of programming finished with 42 graduates. It's actually very prestigious because they run it like a university. So at the end, you get like an NFT, graduated from Aki. And very recently, they also launched an auditors bootcamp. It's running currently. There are 750 students. So altogether, they have roughly 150 graduates from 1,500 students. So please join also the next school of Solana. It's a programming school. It will start next month. Here's a QR code. You can find the URL. Now, who knows what is fuzzing? OK, so fuzzing is basically a software tool which is dynamically testing your code. So it compiles your code, and then it generates random numbers, and then tests your code, 1,000, 100,000, 1 million iterations. We will see a demo soon. The open source tool by Aki is called Trident. And why we think it's useful, because yes, EVM chains have most hacks. Around $8 billion were hacks. $8 billion was hacked currently across all blockchains. 1 billion on Solana. Still, it's 13%, but we think as we provide more value on Solana, this will increase. So fuzzing is a tool which is used currently very normally in Web 2 and also in EVM ecosystem. In EVM ecosystem, the tools are called Echidna, which is a tool by Trail of Bits, Foundry, Medusa, or Wake. Wake is actually developed by Aki for the EVM ecosystem. And for Solana, there is only one open source tool for fuzzing, and it's called Trident. Let's talk about Wake first. Wake was launched in Aki before Trident. It already protects around 30 billion of TVL. Interestingly, it found a medium bug in Lido in a smart contract called Stonks, which has 24 billion TVL. So fuzzing is actually useful. Lido, Axelar, Safe, they use fuzzing constantly because the advantage is once you have your fuzz tests, then you can just continuously use them to run your program every time you have a new iteration. You have a new commit, boom, you just run the fuzzing test when you are asleep, for example. But again, like you cannot just fuzz your code if it's not very well written. So let's talk about the basics very, very quickly. Important is good code quality. You know, use Anchor framework, have peer reviews, well-documented code, and well-structured, number one. Number two, write your unit and integration tests on Anchor. Number three, use fuzzing, and only then go and see expensive auditors. Because fuzzing, you can do yourself, and I show you how. So Trident, the open source fuzzing tool we are talking about right now, was in development for 3 years. This includes Wake. It was launched in May this year, and this is how it works. So when you launch it, you will see, you launch it by typing Trident fuzz run fuzz0, that's your test, and then you can see here it's like launching many iterations to test your code. Richard, are you fuzzing your code? Of course, QuantStamp is fuzzing their code, I hope. So let me now switch to the demo. OK, so I think you still don't see my screen. Do you see my screen? No. So, OK, and I do mirror display. You should now see my screen. Yeah, OK, excellent. So let me just put this. So this is the GitHub that you see when you go on Aki blockchain/Trident. You just copy the GitHub repository locally when you program. You see here documentation. I have it open. Super simple, you know, how to get started, how to start fuzzing. And actually, if you run, and you have some of the examples here if you click. Yeah? So fuzz test, you have several examples, including, for example, Hello World. So now let's take a look. I took the Trident repository. I copied it locally, and here you basically see just the GitHub. Yeah? So I have the Trident, I have documentation, I have the examples. Now, in the examples, I have Hello World, and I'm going to show you Hello World. When you launch your Trident using Trident init, 3 things are important. The first one is it's going to generate a Trident TOML, which is the configuration file. Here, for example, you can specify 2,000 iterations, and what happens if, for example, the fuzzer finds an error. Here I have exit upon crash true. So if it finds an error, it stops. Then second thing what is important is in Trident tests, I have here the output in HFuzz workspace. I have Siga BRT. It's a binary file, which is the output of the fuzzer. We'll see how we read it in a second. And then I have 3 files, which is account snapshots generated by Trident. You don't touch this file. This file is basically just there to teach the fuzzer which accounts are used. In test fuzz, you specify which functions of your program should be called. That's an important file, but it's easy to adapt. And fuzz instructions is the main file. In this file, you program your fuzzer, and you basically just do 2 things. Here you specify what are the inputs to use. So here I have input, self-data input. It tells the fuzzer that it should use all the different numbers. But I can also specify, you know, try with the number 1, try with the number 123. Now, and I also have the second important thing, which is what we call invariant tests, which is if you find an error, for example, if the smart contract or the state of the account is a number 123, stop. So I just specify, again, my inputs and my invariable tests. Very easy. And then I can run my fuzzer. So I am right now here in the Hello World. This is my console. Yeah, I am in Hello World. And I'm going to run Trident fuzz run fuzz0. Run the test 0. Boom. And now, live, the fuzzer is running. I am right now at iteration 356 of 2000. Still haven't found a mistake. Iteration 550. I hope it will find a mistake soon. If not, we'll be here late. Iteration 659, boom, it crashed. It found a mistake. Here I can see, crash is 1. It doesn't tell me the output, but now I know that there was a mistake in my code. So now I run a debug on the output file, which is called SIGA-BRT. Every time the fuzzer runs, it regenerates the same file. So I just have to run right now the command trident fuzz run debug on that binary file. And now debugger will launch. And debugger has this output, and it tells me, OK, there was a mistake in an initialize function on line 36 because, and it hit when the number was 123. And you remember in my invariant test, I had a function saying, if the output of the account is 123, then stop. And he tells me, I had a crash when the number was 123. So now I can go back to my code, and I can go on the line 36, and I can see, OK, so when this self-data input was the number 123, boom, it crashed. And now I actually found a mistake in my code. So please use this yourself. Download it. It's all on GitHub. Actually, we created a Telegram group, Aki Breakpoint, Fuzzing with Trident, where the programmers, as we speak, are waiting for you, to ask your questions. You can also take a look at that same example. Now let's go back to the presentation, please. Who understood? All right, that's cool. I like it. So if you go back to the presentation, how can you actually start even from today? How can you start even from today? Number 1, watch the videos. Number 2, read the docs that I showed you. Number 3, ask in Discord. And of course, connect to the Telegram group, which we just created. Why it's important? Because as more and more software programs of Solana will be verified on-chain, hackers will have access to your open source code, and they will do the fuzzing before you do. So please do the fuzzing before the hackers do of your code, and for this, use Trident. Thank you.